So how does it all work? So how does it all work? Most applications today have the need to fetch data that's stored remotely in some database that's accessible over the internet. That's what servers are used for. Whenever a client needs some information that it wants to display to the user, it sends a request to the server. The server is programmed in a way that it can respond to the request by retrieving the appropriate information from the database and then sends it back to the client. Before we dive deeper into the technical details in the next chapter, let's understand a bit of the historic context in which the concept of REST was developed. REST has been a popular way to expose data from a server. When the concept of REST APIs was developed, client applications were relatively simple and the development speed wasn't nearly where it is today. REST thus was a good fit for many applications. However, the API landscape has radically changed over the last couple of years. In particular, there are three factors that have been challenging the way how APIs are designed. Increased mobile usage, low-powered devices, and sloppy networks were the initial reasons why Facebook developed GraphQL. GraphQL minimizes the amount of data that needs to be transferred over the network and thus majorly improves applications operating under these conditions. The heterogeneous landscape of front-end frameworks and platforms that run client applications make it difficult to build and maintain one API that would fit the requirements of all the different clients. With GraphQL, each client can access precisely the data it needs. Continuous deployment has become a standard for many companies. Rapid iterations and frequent product updates are indispensable. With REST APIs, the way how data is exposed by the server often needs to be modified to account for specific requirements and design changes on the client side. This hinders fast development practices and product iterations. Now that we've got a bit more perspective on the concept of REST, let's go and understand a bit more about the history of GraphQL.
So why GraphQL? Because over REST. Why GraphQL over REST? Because the client devices are in various shapes or forms, or like because users are using more mobile devices. Okay, but why? Okay, I guess yeah. Because more users are using mobile devices predominantly. Because more users use mobile devices, and fetching only required data becomes more crucial. allows only one way to fetch. Allows one way to fetch just the required data. That that can be used in any front end. That's REST. Making changes on the API. REST API is harder to causes more effort on front end to integrate. Has gained only little traction in the native mobile space. The first time Facebook publicly spoke about GraphQL was at React.js Conf 2015, and shortly after announced their plans to open source it because Facebook always used to speak about GraphQL in the context of React. It took a while for non-React developers to understand that GraphQL was by no means a technology that was limited to usage with React. Rapidly growing community. In fact, GraphQL is a technology that can be used everywhere a client communicates with an API. Interestingly, other companies like Netflix or Coursera were working on comparable ideas to make API interactions more efficient. Coursera envisioned a similar technology to let a client specify its data requirements. Netflix even open sourced a solution called Falcor. After GraphQL was open source, Coursera completely canceled their own efforts and hopped on the GraphQL train. Today, GraphQL is used in production by lots of different companies such as GitHub, Twitter, Yelp, Shopify, and their own few.
And how it came to be. The FQL in the context of React. A solution called Falcor. Completely.
Edit on GitHub. Interesting. Over the past decade, thank you. I heard someone saying bless you, so. Over the past decade, REST has become the standard, yet a fuzzy one, for designing web APIs. It offers some great ideas, such as stateless servers. I don't know what that means. And structured access to resources. However, REST APIs have shown to be too inflexible to keep up with the rapidly changing requirements of the clients that access them. So what's your major differences between REST and GraphQL when it comes to fetching data from an API? Let's consider a simple example scenario. In a blogging application, an app needs to display the titles of the posts of a specific user. The same can also display the names of the last 3 followers of that user. How would that situation be solved with the REST and GraphQL? Yeah, so we would get titles of the posts of a specific user. Okay, we would fetch the posts with a user ID, or I guess first we get the user, then based on that we based on the ID of that we get fetch the posts of that user, then we also fetch followers with a user ID. Yeah. Okay, I wanna just make sure, what was payload again? Okay, so you can call it payload when you send a request. Okay, I got my answer. So payload can be used in both contexts. In GraphQL, on the other hand, we simply send a single query to the GraphQL server that includes the concrete data requirements. The server then responds with a JSON object where these requirements are fulfilled. So good. You know what you want, you know what you're gonna get. Using GraphQL, the client can specify exactly the data it needs in a query. Notice that the structure of the service response follows precisely the nested structure defined in the query. Okay. No more over or no more over and under fetching. Yeah. Interesting. I'll read these as well. Or under fetching, that is because the only way for client to download data is by hitting endpoints that return fixed data structure. It's very difficult to design the API in a way that it's able to provide clients with their exact data needs. Downloading superfluous data. Overfetching means that a client downloads more information than is actually required in the app. Imagine for example, a screen that needs to display a list of users only with their names. In a REST API, this app would usually hit the user endpoint and receive JSON array, user data. Yada yada. Underfetching and the n+1 problem. Yeah. Client needs to first download a list of elements, but then needs to make one additional request per element to fetch that required data. Endpoint user ID followers in order to be able to display the required information. The app will have to make one request to the user endpoint and hit the user's followers endpoint for each user. Now this is interesting because you can analyze, because developers only fetch what they need. You can analyze. Which data is being used versus which ones are not. Form of contract that determines what you are going to get based on your request. It's time to learn about some fundamental language constructs of GraphQL because the first glimpse at syntax for defining types as well as sending queries and annotations. Okay, so core concepts. So they have the schema definition language. Yep, I got that part. Two type of name and age. Yep. Express relationship between types in the example logging out. The person could be associated with post. One-to-many relationship between person and post in the post field array of posts. REST APIs data is loaded from specific endpoints. Each endpoint has a clearly defined structure of the information that it returns, encoded in the URL that it connects to. This approach that's taken in GraphQL is radically different. Instead of having multiple endpoints that return fixed data structures, GraphQL APIs typically only expose a single endpoint. This works because the structure of the data that is returned is not fixed. Instead, it's completely flexible unless the client decides what data is actually needed. That means that the client needs to send more information to the server to express its data needs. This information is called a query. Fortunately, we no longer provide the run-in sandbox feature that is demonstrated in the video 1350. We're really sorry for the inconvenience. Okay, no problem. Basic queries. Let's take a look at an example query that a client could send to a server. The all persons field in this query is called the root field of the query. Everything that follows the root field is called the payload of the query. The only field that is specified in this query's payload is name. I don't know if called that. What a code. Mermaid. Interesting. No. Split. Preview. Okay. I want to just delete this for now. I just want a code. And this here, persons, capital. Whoa, what's going on here, man? There you have name. Close the curly braces. Then we close that other curly braces. So apparently this is the root. Root fields. Gotta know what you're talking about. This is the root field. Anything underneath, the only field is spelling. Whoa. Everything under the root is part of the payload. Better know that. I like how the forward slashes turn a little more forward-y when you italize it. Make it italic. So going to return a list of all persons currently stored in the database. Here's an example response. Say example query. Do you think that all they have GraphQL? They do. They actually do. Client also needs person's age. All it has to do is slightly adjust the query and include a new field in the query's payload. Yes, information, for example, if you want to load all posts that a person has written, you could simply follow the structure of your type to request information. GraphQL, each field can have 0 or more arguments. Queries with arguments. Sure. Returns the last 2 elements. Or how do they? Maybe they do it like this. Next to requested information from a server, the majority of applications also need some way of making changes to the data that's currently stored in the backend. GraphQL, these changes are made using so-called mutations. Syntactical structure as queries, but they always need to start with the mutation keyword. Here's an example of how we might create a new pattern. Query route before the mutation also has a root field. In this case, it's called create person. We also already learned about concepts of arguments for fields. In this case, the create person fields take two arguments that specify a new person's name and age. That is specified in the schema. We'll return up to a specific number of persons. Each field all fields under the root is the payload. Can have no 0 or more arguments. That can be deemed as sort of deemed as a filter. Request data. Need at least a root field and a payload field. That's what it looks like. To write new information. Shapes payload. I am very distracted. I'm gonna stop for a while, eat something, then come back. Bye.